Hello! Today we're going to be explaining the AP Calculus AB 2016 free response question number 3, as well as 3 multiple choice problems, numbers 85 through 87, from multiple choice number 2. So let's get started.
For the free response question number 3 from the AP Calculus AB exam 2016, we are given a function g of x equals the integral from 2 to x of f of x, and we're given the graph of f of x. Your very first step should be to recognize that f of x equals the derivative of g of x due to the second fundamental theorem of calculus, which states that when you have a function that is an integral with a lower bound that's a constant, when you take the derivative of this function, your derivative will be the inner function of the integral.
On to part A. In order for there to be a relative extrema on g of x at x is equal to 10, the derivative of g of x must change from positive to negative, because at any relative extrema, g of x must have a horizontal tangent line, and must either go from increasing to decreasing, or decreasing to increasing. So, at x is equal to 10, the derivative of g of x does equal 0. However, g prime of x does not go from positive to negative, or from negative to positive, so there is no relative extrema at x is equal to 10.
Part B. For g of x at the point of inflection, its derivative must go from decreasing to increasing, or increasing to decreasing. Note that this criteria is different from the criteria for relative extrema, which states that the derivative needs to go from positive to negative, or negative to positive. At x equals 4, f of x goes from increasing to decreasing, so x equals 4 is a point of inflection, specifically a point of inflection where it goes from being concave up to concave down.
To find the absolute minima, the maxima on the interval, we need to locate the endpoints and the x values where f prime of x changes signs. In other words, we'll be testing our relative extrema, and the endpoints will plug all of these 4 values into g of x to see which holds the highest and the lowest values. The highest value would be the absolute maximum, and the lowest value would be the absolute minimum.
So for this question, you can see that when x is equal to negative 2, f of x changes from negative to positive. And when f of x is equal to 6, x is equal to 6, f of x changes from positive to negative. You must always remember to include the endpoints, which would be negative 4 and 12. So in the end, we have 4 x values, where x is equal to negative 4, negative 2, 6, and 12. And then we take all these values and put them into this graph to solve for g of x. And you must remember that when you're solving for g of x, you must use an integral, such as the one that we're showing when x is equal to negative 4, which is an integral from negative 4 to 2 f of t d of t, which would be negative 8 plus 4, which would end up being negative 4. So with all this data, we can see that our maximum would be g of x is equal to 8 when x is equal to 6, and the minimum would be g of x is equal to negative 8 when x is equal to negative 2.
We need to find where g is negative. This sounds like an easy task, but it's trickier than it seems. Remember that when x is less than 2 in g of x, our upper boundary will be a smaller value than the lower boundary. When this happens, we need to switch the boundaries to get an accurate value. But when you do that, you need to put a negative out in front of the integral. Remember that switching the boundaries means putting a negative out in front. So using all of this knowledge, we can conclude that g of x is negative from negative 4 to 2. It's also negative from 10 to 12 because f of x lies below the x-axis. So the area of this region will be negative.
Now, on to the multiple choice. In this problem, the trickiest part is setting the expression for the trapezoidal sum. The formula for a trapezoidal sum is 1/2 delta x times the sum of the bases of the trapezoid. It's important to remember that for each of the 3 subintervals, the delta x will be different. and the sum of the bases will be the function of the right and left endpoints of each subinterval.
Next, we have a cross-sectional volume problem. You can see in the diagram what this would actually look like. It's going to be perpendicular to the x-axis. And what we're basically doing is we're constructing shapes that rise out of our function.
So for this equation, you can see this motion picture, which allows you to see exactly what a diagram would look like.
First step is to take the equation of the line and solve for y, so that we can integrate it. For the integral expression, you are going to take the integral of the line equation squared times pi over 8. We do this because the area of one cross-section, which is a semicircle, equals 1/2 pi times radius squared, and in this case, the radius is 1/2 f of x, because it is a semicircle. Simplify that, and you've got pi over 8 times f of x squared. What happened to delta x, you might ask? Well, as the number of cross-sections approaches infinity, the width of each cross-section is going to approach 0, because as you add more cross-sections, the available width for each cross-section decreases.
So for this equation, when you have to implement the area is equal to pi over 8 times s squared, the s would be the top curve minus the bottom curve. And in this graph, we can see that the top curve would be this over here, x plus 2y is equal to 8, and the bottom curve would be the x-axis, which is also y is equal to 0. So when we have s, it would be this value over here, which would be the top curve minus the bottom curve.
In this problem, all we have to do is find the tangent line. First, we need to find the derivative of f of x. Once we have that, we need to set it equal to 1. Once you subtract the 1 from both sides, you can solve for x so that we can find a point where f prime of x is equal to 1. One way we do this is by using a graphing calculator to find the zeros of 4x cubed plus 4x squared minus 1. First, type this function under the y is equal to button. Press Calc 2 to find the x values of the zeros. In order to get the ordered pair for the tangent line, plug the x value of 0.237 into the original equation. Next, use y is equal to mx plus b with m is equal to f prime of x is equal to 1 and plug in your ordered pair to get the b value.
Hang in there, guys, and good luck on finals. Thanks for watching.